Let's jump straight into the next one. Again, a pretty interesting topic because I've been working on getting some visibility on proper detection coverage in knowing the results of well, of basically what are we doing, and the fact that we get, for example, when we're testing a new use case, we get zero results. Does that mean that we don't have the data, or does that mean that our use case is broken? And when I read this summary or this well, this pretty impressive short recap of the talk, if you will, by Tim and Fred, who both work at Booz Allen, I was very excited. We are running a little bit behind, so I'm immediately going to hand over the word. I would say, Tim, Fred, go ahead and good luck and enjoy the talk.
All right, great. So yeah, well, let's jump in right away. Like you said, thanks, Eric, for the introduction. So my name is Fred Frey. I'm the technical director at Dark Labs. It's a research and development and rapid prototyping shop within Booz Allen Hamilton. 20 years of cyber offensive experience. First 16 was pen testing, red teaming, mostly offensive. And then 4 or 5 years ago, stepped away to start up our Dark Labs or Booz Allen's threat hunting program. So have a bit of experience of red, blue that we're going to share with you. Tim?
Hey, thanks, Fred. So Tim Nary, I've been with Booz Allen for a decade, primarily on the offensive side, also doing research and development. I like to consider myself more of a recovering red teamer. I've joined the purple side now and like working hand in hand with defenders because I think it's a really challenging problem set.
Awesome. All right, so we'll jump right into it. So, setting the stage, 5 years ago, as I kind of mentioned, we came from a red team background, and we hired in a bunch of blue teamers, detection engineers, and we're really ramping up this, hot topic, threat hunting. We had a very bullish attitude towards threat hunting at the endpoint as well as the network. That proved out to work out well for us. But one of the challenges was, hunting at the endpoint there's a lot of challenges, right? It's not as maybe uniform as the network, right? So BRO and PCAP and net flow data is pretty easy to handle. But when you start talking about endpoints, you have various different EDR technologies, Windows event logs. They can be represented in different ways, and there's not a lot of standards, and there still isn't today. So we needed to have a lot more rigor and standards developing these network detections. So we started rapidly prototyping. And I'll save you all of the iterations of our lab space of how do we get red teams emulating the threats, blue teams trying to detect those threats, and how do we iterate through that process. But I'll save you the stage, but we're just going to jump into kind of the solution. So you get to fast forward through quite a few bumps and bruises. So just to set the stage, a typical analytic development process kind of looks like this. So you are reading a tweet or a blog or an article, or maybe your CTI team, handed you this report, and you have to, go off of it. So how do you're going to write an analytic that's describing those behaviors and translate it from whatever that PDF or that third party, vendor or, company has written. They've often don't have the same security stack that you have. So you now have to take it from Splunk and write it to Elk, or take it from a Carbon Black watch list and convert that to, an Elk, Sysmon, or, vice versa. So there's many different translations that have to happen. And the other challenge is that you don't know the attack as well as the person writing this blog post article. And in many times you can't emulate it quite the same as that they used to do. So how do you run this in your sim? You're going to copy paste, you're going to translate, you're going to run this in the sim, you're going to hold your breath. And, I will say that there's this difference between a junior analyst and a mid-tier to, senior analyst in the results of that, right? So you've copied this analytic, you've ported it, you've hit enter, and you get 0 results. There's one of 2 feelings you can feel. You can either feel really happy that it's a Friday afternoon, you hit, you search for this threat and you have conclusively determined that it is not in your network. That would be a very naive way of thinking about it. Junior people typically have this reaction. The other reaction is the opposite, where you have this deep uncertainty about your feeling. You gave it your best, but you're not 100% sure if the threat really isn't in your network, or if something went wrong along your understanding of the threat, translating it, or even in your syntax. So kind of hinted at it, but what if I told you, right, 0 is kind of the scariest number when you're doing detection engineering and you're trying to take somebody else's third-party knowledge and work it in here. So how do we combat that? Well, let's give a little example. So this is just a very, very simplistic example of like a net local group. Here, my own Splunk kind of hidden, so I kind of want to mute this. Let's see if I can mute it. Okay, so here's a simplistic example of an analytic that you might get from either translating or directly from like a source. So what's wrong with this? Well, it turns out there's quite a few things wrong with this, right? And so this is intentional that we created this just to show some of the common errors that we're seeing. So we're seeing kind of human errors where you're using a backslash where you should have used a forward slash. There's command line. If you look up here, there's command underscore line, but in your network, it's command line with like camel case. We've seen a lot of single quotes versus double quote errors. We've seen a lot of, maybe a single space detection where there should have been double spaces, or quite honestly, should be a lot more robust such that the analytic can accept a hacker typing in 2 spaces or 3 spaces or a million spaces, right? So there's this robustness to commands that you need to take into consideration. Paths needing to be double escaped with backslashes. And even some weird quirks, which I'm sure a lot of people will chuckle that, net.exe is not net.exe when you run it from a command line, right? So if you type in net.local group administrators, if you're enumerating local group administrators on your box, it actually turns out it's net1.exe. And I actually didn't know the answer to why this happened, but Tim did some research and he added it's Y2K, right? So we can blame Y2K for this net.exe. So not only from syntax errors, how this can be a problem, right? Syntax errors can be a real big thorn in our side, and we've kind of enumerated some of them, but these are some other examples of just outside of syntax errors. We might not have the data that is required for our analytic to work. We also might have the data, but only in 20% of our coverage network, right? So especially with this work from home mentality, right? So there's a lot of remote workers that are doing things, behaviorally very different than they did when they were working in the building, in the corporate environment, right? So we're missing, much of our data if you're not engineering, if your data engineers are not, organizing it that way. The other thing is, is it flowing to you, right? So it might be going into your Carbon Black, but then you might have a filter in your Carbon Black forwarder that's not forwarding all of your data into your, Splunk. Is it being retained for a reasonable amount of time? Is there logic flows? That's the previous slide. And, the last thing is just, is it even detecting what the actual thing is that we're supposed to be detecting from that blog post? So when we hit 0 results, right, this is what we usually think of. We think of a true negative, meaning there's no actual attack and there was no attack detected by our analytic, and we can kind of, snooze, right, like good stuff. But the challenge is it also could land in this false negative. And this is where we're sweating, right? There actually was an attack, but our analytic did not detect it. And so that's really bad because we knew of the attack. We have this false sense of security, right? We tried to detect it. We knew we were supposed to detect it and we failed at our job, right? So this false negative is like really bad. True positives are always great, nothing to talk about there. And then obviously if no attack happened, but we are detecting an attack, you have a problem with false positives in your analytic, right? And that's something that needs to be tuned. So how do we fix this, right? More testing and more testing rigor, and it has to be baked into your purple teaming process. And we'll get into why this isn't just a blue team problem and why this is more than a blue team problem. We need the red team to fix this with us. But looking towards computer science, I have a computer science background, and we are banged into our head the software development lifecycle, right? Analyze, test, or analyze, design your code, code your code, have second person look at your code, test it against use cases, both unit test and system test, and then you can release it into the wild. Unfortunately, that's not how it works in blue teamers, right? We are pressed for time. We are really cutting it close. We have so much, there's so many more detections that we need to address that we can't get to. And so we're always running behind. So we shortcut this process. There's often not a lot of oversight into this process. So, it has to be baked into a process that can be tracked by leadership and encouraged. And the other thing is, it's not also just about putting that process there. Processes shouldn't slow you down. They should speed you up. So whatever process and platform you're using has to be optimized for, to save time using it, not reduce time. So there's a lot of promises that we'll get to and treat later. So, detection as code, right? This is a big thing. This is kind of catching on, that we have a lot of very talented people that are detecting mimikatz or a privilege escalation or a lateral movement. And we are trying to detect that across, all sorts of vendor products, right? FireEye, CrowdStrike, Carbon Black, Microsoft, Defender, all of these things. We have the same goal as blue teamers. We just need to detect it. And a lot of the research that's going into this is getting, channelized or siphoned by vendor, right? And vendors, if I detect it in Carbon Black, I'm not porting it over to FireEye. Or if I detect it like SolarWinds, released amazing OpenIOC XML-based detections, but we all needed to take that from XML IOC-based and then detect, against another vendor. So, this Sigma project is interesting for, we think it solves probably like 85% of the normal cases. There's a lot that it doesn't detect, but we think Sigma is a really great step for, sharing analytics and detection logic. So I kind of hinted on this, but I will leave you on this slide, I believe. What are the 3 things that we want to test for? So on our team, we absolutely have this doctrine of every analytic detection engine analytic that we create, we need it to false positive reduction. This is the obvious. This is the one that every blue team is doing today, right? You run it, you run an analytic in Splunk and you get back 10,000 results. You realize your errors. You try and reduce those errors down to, okay, exclude this, filter this out. Oh, I had a logic here. So everybody's doing false positive reduction. But really, the magic in really separates, the baby blues from the big blue teams is your true positive validation and your robustness. And Tim's going to talk a lot more about how we do that. But true positive, does it really detect the thing that you intended to detect? And then the question is, now it does detect that. The extra step that a lot of teams aren't doing right now is robustness checking. Okay, it detects it in this one case where a script kiddie downloads it from GitHub and executes it, but there are 1-step, 3-step, 4-step removed variations of that code that hackers can modify. And are you detecting on something that is a bottleneck in the detection, or are you, being too specific on your detection algorithms? So I'll turn it over to Tim to talk about more of our process and how we think about this. Tim?
All right, awesome. Thanks, Fred. So yeah, let's dive into this. Again, we're looking for some practical things that you could go ahead and processes that you could start implementing today. So in terms of analytic development and thinking through what this kind of workflow looks like, we always start with threat intelligence. And threat intelligence doesn't have to be necessarily anything formal, like a threat report or some sort of subscribed threat feed. It can be a tweet from Twitter, it can be a blog post, it can be even just perusing the MITRE ATT&CK framework and say, today I want to detect, WMI or bits jobs or something like that. So being able to, understand and have some sort of source, because usually we find if you're not looking at threat intelligence, you may not necessarily be grounded in reality. I know a lot of red teamers like to focus on these, fancy attacks that, maybe are a little more theoretical and a little less practical. So, being able to kind of take a look in something that, you're actually looking at detecting is really important. From that phase, you analyze that threat intelligence, and you're going to want to go ahead and create analytics for that. So you're going to read that report, and you're going to kind of pull out, again, we really love MITRE ATT&CK. So pull out those techniques and procedures that they're using. So, things like WMI persistence or, scheduled tasks or, credential dumping. And once you go ahead and you create those analytics, the next piece is going to be, again, kind of this process here where we want to do this testing and validation. So, like Fred mentioned, you're always going to want to do your false positive reduction. So taking that analytic, testing it across your enterprise SIM, your EDR, and making sure it has the right number of false positives or an acceptable number. The goal isn't necessarily for every analytic to always have 0, which we'll talk a little bit more about in robustness, but it's something that you can live with and tune to that level that it's useful for you. If that's going to be an alert that you're going to have to respond to right away, or something that your hunt team might take a look at in the next, few days or however that, may be. We always want to look at true positives and validate that. This is especially important where you're going to have, a test lab set up and your red team going through and actually making sure that you can detect, these things that the analytics say they do. And that again is what's going to give you that confidence to sleep, comfortably at night that, you're able to detect on those things and you don't have to fear that dreaded 0. Last piece is again, robustness. So, kind of like taking a red team approach to something, share the cards, put it all on the table. I don't know how many teams actually have the red teamers looking at the detection logic and saying, hey, is this a good piece of detection? How could I evade this detection? Being able to actually kind of like red team these analytics is a kind of a novel concept, I think, and that really adds to robustness when, both teams, share exactly what they have, put all the cards on the table. And again, this kind of leads back to this whole iterative process because you're going to be creating these new analytics and then you're going to want to go through and modify and test again to make sure you're still, reducing false positives and have these, validated true positives. So again, all of that output is going to give you these nice production ready, high quality analytics. So next slide. Simple real world example. So we were hunting in a client and, they had some developers and they were worried about living off the land. And they were in particular looking at, detecting usage of mav inject. So they went to, the Sigma repository, great open source project. They found this analytic detecting mav inject on the command line. And you can see here, maybe it's not the most robust analytic. It's looking for command line inject running. In some environments, that would be, 0 false positives, 0 hits, very limited number. But in their environment, they had, next slide. Yeah, their environment, they had 27 million results. So again, these are the things that you're going to have to deal with. In their example, if you browse through all these pages, it turned out that their semantic endpoint tool was actually the one causing the problems here. So again, you could add that as a filter. You could add a specific process name with that command line pair, but there's definitely things that you could do to tweak this analytic to give you, again, the right and acceptable number of false positives. Next slide. So now we want to talk a little bit about this kind of true positive validation and robustness workflow. So again, that previous workflow is definitely very kind of synchronous where you start from one side or the other, but realistically, most of your teams are going to be working asynchronously. So your blue team is going to be, they're going to have a detection backlog. They're going to be creating all of these signatures, putting these together. And, maybe they get lucky and they have something that there's already an attack and it's validated, but more likely you're going to have this library of, untested, unproven signatures that you're going to want to go through this validation process. On the flip side, your red team is going to be going through creating all of these attacks, and they're probably going to be undetected. And both these teams need to kind of be working asynchronously. And again, the goal is to kind of meet in the middle. So you're going to want to create an analytic library, a threat library. And as you're going through, there's different data that you're going to want to capture. So, for my analytic library, obviously I want, title, description, notes, kind of what I'm trying to detect, why I'm detecting it, validation status. So is this, detected at what confidence, is this an alert? Is this more of a hunt analytic, a haystack? All of your exclusion filters and, link it back to examples of true positive logs. Because at some point you're going to want to have to, make a modification. You're going to want to see, okay, so what does this hit on? What's the true positive look like? What does the false positive look like? Because some analyst, when it triggers, is going to need to know like, hey, okay, is this hit actually, a valid true positive or something? So having that information is really critical. And again, having that analytic library where you can keep all that information really helps because a lot of these production tools just don't allow you to wrap all that metadata around it. Similarly, with a threat library, again, you're going to want to track a lot of the same things. So title, description, actual event logs, mapping it to MITRE attack, and importantly, also kind of labeling these threats. So tell me what attack was trying to be done. When did this happen within this threat library? Something that's kind of a living reference where you can go back and you can look at these things. And again, all together, as you're going through this workflow, the goal is to have these validated true positive analytics that you could go ahead and confidently deploy. So next slide. So talking a little bit about true positive validation, how we would go about testing this. Again, we like empirical evidence. So we're actually going to emulate the threat. That's the job of your red team. We're going to capture the logs and artifacts and see what they have. It's usually working with your blue team. And then again, working together to actually validate these analytic kits. Lots of great open source projects here. I don't have time to kind of deep dive all of them, but we're going to touch on a couple. Usually these kind of fall into a couple different categories. One of them is pre-captured event logs. So projects like Mordor, EBTX, attack samples. Somebody's already done the work. They put this into a library for you, and you can just go and you can browse based on a technique. There are breach and attack simulation. I call them breach and attack simulation light tools. Obviously, there's a whole market segment for this, but again, these are projects like Atomic Red or MITRE's Caldera, where you can go ahead and you can run, attacks kind of out of the box in a very repeatable way and an automated way, importantly too. Last piece are these kind of spin up detection test labs. And again, our slides are already a little bit woefully out of date. Shout out to Roberto and the Simulan project that, the Mystic team released last week. But I think that kind of falls in that vein, and maybe a little bit of a mix with that in Mordor, where, you as a red teamer can go ahead and you can run these attacks, and you can start to kind of see what these detections are and start to create this kind of living repository here. So again, just kind of touching a little bit more on some of these. I did mention Mordor, great project. Again, what their goal is to, take a bunch of these attacks and, both small and larger data sets, capture the event logs and JSON, capture the PCAPs, and make it very easily digestible, understandable, and referenced, so that you have this, threat library that you can start, going through and using. So if I want to know, hey, what does Mimikatz look like? Hey, I could go to that credential access folder. There's probably an example that I can do without having a red team to go and emulate it. Next project, again, Atomic Red. I'm sure a lot of people are familiar with that. So if you actually do have a red team, or you want to actually see how that, works against your environment. So, I've got a specific EDR, a specific SIM, and I want to, again, test the data flows, the pipeline, normalization, all that sort of stuff. You could go ahead and you could run Atomic Red Team, and that's going to generate those event logs in your environment. So you can test kind of end to end what's going on. Next piece is, detection lab. Again, there's lots of options here. This is really kind of putting it together where, maybe I don't want to be running certain attacks in my production environment. I don't want to, run something against the domain because I'm fearful of what's going to happen. So having a detection lab or like a red team test lab where you can run these attacks, a safe environment. Again, they set everything up for you where you've got, small Windows domain, logs are forwarded, lots of telemetry data, network packet captures, easy access. So, kind of really tying all these things together. And then that kind of leads to, our own approach to this of, when we were going through, we really wanted to kind of take the best of these things and, really combine them. So, as trying to pass off, information to a blue teamer, as a red teamer, I would, emulate an attack, and I would, put it together. It might be, started off very simple where, we were doing this on a local VM, and I maybe take a video screenshot, do a little desktop recording, and I, put that together in a GitHub, or, even worse, a spreadsheet. But again, we all start with something simple like that. And starting to create a threat library where, again, how can the attacker see, or how can a defender see, okay, so what was the red teamer trying to do here? What attacks, what am I supposed to be looking at in the sea of event logs? Because, now I've got, this sample here, and I need to see, I know that they did credential access. Well, what does that look like? So being able to label those attacks and see the analytics, and really just kind of meshing all of this kind of up into this, really nice threat library with, keystrokes and packet captures and all of that. So moving on, robustness. So again, this is really kind of a bonus, but it's how can you go through and make an analytic better? So what's easy, hard for an attacker to change, other ways that you can detect it. And again, it's kind of going to be a spectrum here of, very high confidence, very low false positive things to, more haystacks, like all PowerShell or all process creations, which again, interesting to look through, but not something you're going to manually go through. So real world example of this, in this example, we were looking at, detecting WMI. So went to MITRE's webpage, found this threat intelligence report on WMI-exec.vbs and some usage examples. And then our team went ahead and we started trying to create analytics based off of this threat report. So next slide. So this was, again, first iteration. You can see first one, looking for process name, parent process name, command line, with WMI-exec.vbs. Another one, a couple examples here. So yeah, let's kind of show some of these things here. So in terms of robustness, that first example, obviously this is kind of more like an indicator compromise. It's very brittle. Even the CTI report showed that an attacker renamed this binary when it was dropped on disk. Another analyst took a look at this. This one was more flexible, but again, they didn't really read beyond the threat report. So, there was another switch that the user could use to run a single command instead of more of an interactive shell. Not to mention the threat intelligence only was talking about using C script to launch it and not W script or other ways of executing it. Another one was looking specifically at this WMI DLL that they were using as a temp file. And again, if you actually open up the code, again, kind of talking about this like red teaming your analytics, you can see that this is very easy for a red teamer to change. I mean, it's line 4 of that code where they can, change that and break this analytic. So we went through going back and forth with this, and eventually we came up with an analytic that kind of looked like this, where, again, doesn't look a lot like the threat intelligence report. We had the WMI provider host service, and we wanted to see what, child processes that spawned, and we knew that this specific technique has to redirect that output to a file. So it would look kind of something like this.
Now, one more thing to add to this previous slide that Tim mentioned is this is the purple is the feedback loop that the red team and other blue teamers are giving back to the original author, right? So the original author submits, number 1. The feedback is the purple. They revise it to number 3, but they get more feedback, 3, 4. And then you land on something that's very robust, and 3 or 4 different analysts have had eyes on it, and it creates a very robust experience. So, actually, yeah, robustness in detection. It's very interesting. You do want to have those IOCs, like that first one that was a bullseye. We would call that a bullseye, where it was an exact hash of somebody downloading or an exact name that was from GitHub. It was the WMI VBS script that's pretty popular for lateral movement. We want to detect on the exact hit that's very high confident, because we know that pagers should go off, right? And yes, Olaf, I am dating myself. I am 42 years old. I see you in the chat. Yes, pagers going off. There's another third thing that dates me there. Bro versus Zeke, and Ethereal versus Wireshark, and now pagers. So yes, robustness, detection, and depth. We do want to hit on the exact thing that we want to match. But we also want to have more robust analytics that wrap around that, right? So things like the classic example is I want to see all Microsoft Outlook products that are spawning shells, right? PowerShell, CMD, BinSH, things like that. That would be what we call behavioral analytics. We want to have that layer, and that's very kind of known threat behaviors. And then we want to take a step back, and when there's time, there never is time, but to detect unknown unknowns, you really have to have these big haystacks, right? And the big haystack would be all PowerShell commands that have like, not popping up the window, right? Or attacking code or things like that. These big haystacks that are gonna not be necessarily false positive, but they're gonna be things that you should dig into. So we're running short on time. Actually, we're over time. So this is kind of where we started with trying to piece together a lot of open source threat libraries to achieve our first false positive, true positive, and robustness detection. But the challenge is that they're very distinct and unique in their strengths and in their, not their weaknesses, but their weakness of all of these open source tools is that they're all separate. And what we need to do is we really need to combine these into one platform where analysts can provide feedback. So like we kind of mentioned, we're teasing out, we're not ready for prime time, but we do have this in the works where we can take in, Sigma analytics, breach attack simulation tools, test them, capture the sandbox, of what that malicious activity is, run all of the analytics against it, rank it against your network, and then kind of push it out to the community. So this is our hope. This is our vision. We're working towards this. hopefully the end of the summer. Of course, Tim's going to kick me and say this is recorded, so promise them the end of the year. So that's where we're at. And I'll leave you on final thoughts. You can read it, but process is key. And having one platform where red teams and blue teams can collaborate in one unit, that's what we think is missing from purple teaming. So back over to you, Eric.